So on number 6, we got the square root of 6x times the square root of 9x cubed. When you're multiplying, you just put everything under the same roof. So 6 times 9. I'm going to rearrange things too. And we got x times x to the third. Your choice, you can combine those. You could multiply the 6 and the 9 and get 54. You could leave it 6 times 9. You can multiply the x and x third, which would be x to the fourth. Or you could leave it like that for right now. It doesn't matter. But you want to put everything together. And then, like homework last night, start breaking things down. So 2 times 3, 3 times 3, and I end up with 4 x's. And you look for pairs because the index is 2, it's a square root. And so then this tells you how to rewrite this in such a way that you can take the square roots of stuff. So everything that's circled, we're going to be able to take the square root of. So the square root of 9, the square root of x squared. Everything that's not circled, we won't be able to take the square root of. So the 2 times 3, which is 6. And so we end up with 3 times x times the square root of 6. Number 7, same idea. 60 times 15. Numbers are getting a little bit bigger here. You could multiply that out, but you may not want to. X squared and y to the third. And then start breaking these numbers down. 60, 6 times 10. 6 is 2 times 3. 10 is 2 times 5. And then 15 is 5 times 3. Two x's, 3 y's. Look for pairs. So all the numbers get circled. So that's telling you that 60 times 15 is actually a perfect square. What would that be if you were to multiply 60 times 15? Yeah, 900. And 900 is a perfect square. It's 30 times 30, so it's going to end up that way. Okay. So this product gets rewritten. I have 2 2's, so that's the square root of 4. 2 3's, that's the square root of 9. 2 5's, that's the square root of 25. 2 x's, 2 y's, all that was circled. And then the last thing that wasn't was just the square root of y. So we get 2 times 3 times 5 times x times y. All that gets rid of the square root, left with the square root of y. And then you multiply everything together. So that's going to be 30 xy root y. Okay. So as you see, there's multiple ways to do this. I'm demonstrating one way. But as you get more comfortable with this and you're like, I know what's going on here, you may end up developing a quicker way for yourself, and I'm okay with that. Okay. All right, number 8. So let's do the ones, twos thing, right? Where one person's going to explain how to do it, one's going to write. Okay, so still got your groups of 2. Sue and I, we're working together, right? And let's go, the 2's are explaining to the 1's. So the 2's can't write, the 1's do. So same ordering that we used last time. Cube root 7. Okay. How do we do? Okay. Any questions? Okay. So that's multiplying. Now let's talk about adding. Okay. And before we do, let me just remind you of some stuff you already know about adding. So if I have 2x plus 3x squared plus 5x, and I want you to add that, what would you do? Lindsay? Add the 2x with the 5x, right? So 2x is going to add with the 5x. Can I add it with this? Why not? Because you got a different, it's x squared. It's still the same variable, but it's x squared, so it's not a like term, is kind of maybe how you were learn that before, right? So you'd say 2x plus 5x equals 7x plus 3x squared. Now, when you add the 2x and the 5x, you added the 2 and the 5. How come you don't add the x and the x? So let me make it, let's take away the x. Say I do this. 2 times 5 plus 3 times 5. Right? Could I do this and say, well, that's 5 times 5, where I'm just adding the 2 and the 3, but I don't add these two? Is that, because that's exactly what we were doing, right? So, and I know someone was trying to answer, and I kind of cut you off, but why don't we add those fives right there? Elijah. It has to do with multiplication. Yeah? So you're checking, you're verifying it works. So it's a rule that works, but why? Right? Yeah. Okay, so it's combining like terms. Like combining like terms. They both have a 5. Do you guys remember what multiplication is shorthand for? Repeated addition, right? So this is really represents 5 plus 5. And this really represents 5 plus 5 plus 5. Right? And now you can see, yeah, I got 5 5s. So I got 2 5s here and 3 5s there. Now I got 5 5s that I'm adding up. Another way to think about it is factoring. Okay? These both have a 5. I could factor out a 5. If I factor out a 5, what's left? 2 plus 3. The 5s are gone, and I just get a 2 plus 3 here, and then again you end up there. Okay? So just a reminder of what you guys have been doing. When you add, they have to be like terms, meaning everything after the coefficient's your number, has to be alike. Same thing applies with this. Okay? These are like your square roots are kind of like your x's and your y's, and they have to match exactly. So on number 9, they don't match. One's a square root of a, one's a square root of b. That's like having an x plus y. Can't do anything with that. But the next one, square root of a plus square root of a, those are like terms. We can add those. What do you think the answer is? It's like x times x, sorry, x plus x, which would be 2x. So this is going to be 2 square root a. We're not multiplying them. Square root of a doesn't change. What we're doing is we're adding the coefficients. There is a 1 here and there's a 1 in front here. Not the index, but the coefficient is a 1. That's what we're adding. So on number 11, could we change that one? You said xy square root a? Close, but not exact. I like to try. Anybody else want to try? Yeah. XY 2 square root of A, like that? No. So what you're going to want to do is you're going to want to only add these, and the square root of A is going to stay the same. So x plus y square root of A. Okay? And the way to think about this is factoring. The factoring out a square root of A. I could divide both of these by square root of A, put it out in the front. It's a distributive property is what it is, in reverse. Because if I said to distribute this, you'd take the square root of A and multiply it with the x, and you multiply it with the y, and you get this answer. So you're using the distributive property in the opposite direction to get that answer. Number 12, could we do anything with that? No, because one's square root of A and one's square root of B, so that's as much as we can do. How about 13? We could do this one. What is it? 2 square root 7. How about 14? What is it? 5 square root 7, because you're just adding the 2 and the 3. How about 15? 15 we get stuck, right? Because one's a square root of 7, one's a square root of 63. You cannot add them if the square roots don't match. That's why I'm saying multiplication's easier. If we had a multiplication symbol here, we can combine it. No problem. But when you get to addition or subtraction, then things need to match up. We can do something on 15 though. Something that we've already learned. Yeah. We can simplify 63. 63 is 9 times 7. 9 is 3 times 3. Okay. And so we've got a pair of 3's here. And so you get 2 root 7 plus square root of 9 times the square root of 7. So that square root of 7 is coming up now. And we know the square root of 9 is 3. And so we get the same answer to 14, 5 square root 7. So now that we see 16, we know we can't add them like it is, but we may be able to add them after we simplify them. Okay? Careful though, when there's an addition or a subtraction problem, there's like this invisible wall between them. You can't intermix them. So if you break stuff down for the 24 and break stuff down from the 72, and you see a 3 over here and you see a 3 over there, you can't circle both those, right? You got to treat them as two separate problems, get the answers, and then if they both have the same root, then you can add them. If they don't, then you're just stuck where you're at. Okay? So let's check it out. 24. God bless you. Is 4 times 6. 4 is 2 times 2. 6 is 2 times 3. I get a pair of 2's. So this is the square root of 4 times the square root of 6 plus 72 is 9 times 8. 9 is 3 times 3. 8 is 2 times 2 times 2, or 2 to the third power. Looking for pairs again. We get the square root of 9 times the square root of 4 times the square root of 2. We're not done yet, but will we be able to add these? Probably not going to work out, right? Because here I'm not going to be able to get rid of the root 6. Here I'm not going to be able to get rid of the root 2. So this just keeps simplifying. So 2 root 6 plus 3 times 2 times root 2. And this is 6. And so we get 2 root 6 plus 6 root 2. And that's as much as we can do. Let's see. Okay. Let's do another one. 24 and 18. We just did 24, right? We did it in 16, so we know that becomes 2 root 6. You see where I got that from? Okay. So we don't have to do that part again. But we haven't done the square root of 18. So that's 9 times 2. So we end up with 2 root 6 plus 3 root 2. And again, still can't add them. Try number 18. Okay. So I looked at almost everybody's work. I didn't look at that group, but almost all of you did it the same way, except for Matthews. And again, I don't know what you four did. And I want to show you what Matthews did. Right? That's how he started. Does that make sense? Could he do that? Right? Because you got 1 here and you got 5 here, and they both are 4 through to 81. Why not? Now, did the rest of you do it wrong? No, not at all. We're all going to get the same answer, 18. I just want to show you another way. Okay? So 81 is 9 times 9. Gives you 4 threes. And you're looking for a set of 4 because the index is 4. And so this is going to be 6 times 3, which is 18. Is 19 the same problem? Almost, except for the index is different, right? Index is 3. How's that going to change our answer? What's that? It's going to be irrational. We could start the same way. We could say this is 6 cube root 81. We still get 4 threes, but we can only circle 3 of them now instead of all 4. Right? And so we get 6 cube root of 3 threes. You could write 27, or you could write 3 cubed, and then we're left with 1 more. So we're still going to get our 18, but we got a little extra, that cube root of 3. Okay. So there's 2 left, 20 and 21. Let's do the ones now, talking to the 2s for number 20. Okay. You're 1. Kind of lead number 2 how to do 20. Seven fourth root 4. When I broke down the 64, I got 6 2s. You should have gotten 6 2s. 4 of them I was able to get rid of because it's a 4th root, and that's how I got my 2 out front, and then 2 of them were left underneath, So that gave me the 4th root of 4. For the 2500, that's 25 times 100. So I broke it up. So I got 4 5s and 2 2s. And so I ended up with 5 4th root 4. And then I added the 2 and the 5, 5 to get the 7. Okay? And then 21. So 16 is 4 times 4. And I'm looking for a pair, so I'm just going to use that pair. You could keep breaking it down, but don't need to. X cubed. I have a minus sign this time, not a plus sign, but it still works the same. Just like you had like 5x minus 3x. Still do the same thing. Over here I have 5x's. I can pair those up. And so let's see what we have. So on the left-hand side, we already had an x out in front. Need to carry that one down right there. I got 2 4s, so that's the square root of 4 squared. 2 x's, square root of x squared. And then 1 left over. Minus, I already had a 3 out in front. And then simplify this. So this is x times 4 times x times the square root of x minus 3 times x times the square root of x. So what do I get here when I multiply all this together? 4x squared square root x minus 3x squared square root x. Can I subtract those? Yes. And when you do, I can only subtract them because these two things match. Not just the square root of x, but also the x squared matches. If this was an x and this was an x squared, I'd kind of be stuck still. Okay? So 4 minus 3 is 1. And so my answer is going to be x squared square root x. Right. So it is